We're going to be factoring polynomials completely and solving equations where we have to factor completely today. And we're basically going to be putting all the stuff that we learned for the last half of this chapter all together. So you have to basically think about what does it mean to be factored completely first. So when you're factored completely, you're basically breaking everything down to all the possible factors that you multiplied. All right, so let's write this down. So polynomial expression written as a product of unfactorable polynomials. So they could include monomials, binomials, trinomials. So remember, what does it mean to be not factorable? That means there's no GCF you can take out, right? You can't do the puzzle. And connect to that, no special patterns or shortcuts work. Okay? So that's basically all we're doing. We're just going to start from start to finish and think about, well, what is it that I can take apart? And if you look at the summary here, the guidelines, always start with looking for a GCF. Sometimes your GCF is 1, that's okay, but always start with the GCF because that'll make the expression in the parentheses smaller, easier to work with, and to help you factor some more. Okay, number 2, this is optional. So if you don't recognize the patterns, that's okay, skip it and factor, just like we've been doing before with your, you know, your puzzle, etc. Okay, oops. So 3 and 4 are kind of linked together. So you're basically just factoring by grouping or factoring using your puzzle. So this, again, is something you want to do if it's possible, because it's perfectly fine to have an expression that's not factorable. That just means we can't go any farther. All right, so those are just some additional things to think about for the concept. And then let's look at a couple examples. And I really think the more you practice this, the better it gets. So always start with the GCF. So I'm going to scoot this up a bit and let's get started with the GCF. So, oops, let me get my pen back. 2x to the third is 1 times 2 times x times x times x. 6x squared is 1 times 2 times 3 times x. Negative 2x, bringing that negative with the 2x there, is a negative 1 times 2 times x. What do they share? Remember, it has to be in common for all three now. So even though there's a positive 1, the third one's a negative 1, so we don't want to circle that. And then I'm going to see one group of 3x's. So my GCF is 2x. And just like we've done before, right, take out what's left over. So I see we have a 2x on the outside, x squared plus 3x. Ooh, I forgot an x there. There you go. Plus 3x plus, or sorry, minus 1, because that's a negative 1. Okay? So we don't want to stop here. We want to see, can I keep factoring? So I might look at that and be like, well, I don't see any special patterns here. So let's try out the puzzle. So multiplying x squared times negative 1, we get negative 1x squared. And then put the 3x below. I'm going to ignore that 2x because the 2x already came out. It's already one of my factors. So I'm just, again, just going to bring that back to the answer and work with what's in the parentheses for the puzzle. So I might look at this and say, okay, what times what is negative 1? The only way I can get negative 1 is if I have a negative 1x and a positive 1x. But wait a minute, that doesn't add up to 3x. So this is not factorable. And that's okay. So remember, that's why I said this is only if it's possible. So since it's not factorable, the smallest factors I can break out are just 2x, x squared plus 3x minus 1. So that's as simple as it gets. Okay? Taking a look at B, let's start the same. Even though it's a binomial here, remember we have special pattern for binomials, and it's also possible just to take out a GCF and stop. So let's take a look for that GCF first. So 5x to the fourth, 1 times 5 times 4x's, negative 45x squared, negative 1 3, 3, and 5. Remember, if you need to do a factor tree, go for it. I see again 1 and -1 are not the same, but I do see a pair of x's. So there's my pen. Another pair of x's and this little pair of 5's. So that makes my GCF 5x squared. I'm going to bring that out front. Whatever's left over inside, so x squared minus 9. And then you want to think, well, can I keep going? A trick to help you decide if you want to try additional work is if you do have something, an x or a y or a variable that has a power that's 2 or higher, you may want to try to factor it, okay? So this x squared minus 9, you could do your trinomial, so you can say this is x squared plus 0x minus 9 and do your puzzle, or use the shortcut. It's up to you. I'm going to use a shortcut because I recognize x squared minus 9 is a difference of 2 squareds. So my a is x and my b is the square root of 9, which is 3. So this is just x minus 3, x plus 3. And then I'm going to put it all together. So my final answer is 5x squared times x minus 3, x plus 3. That's everything factored completely. Okay? So we can now do this to help us solve equations and use that zero product property. And again, I think the more you practice it, hopefully the more you're going to see what's factorable, what's not factorable, the more you're going to be more comfortable with everything. So just like when we talked about solving equations before, we got to make one side 0. Otherwise, the zero product property doesn't work. Right? Because we want to use that zero product property. All right, so I'm going to take that 3x to the third plus 6x squared equals 24x. I'm going to take away that 24x from both sides. And then we're going to get 3x to the third plus 6x squared minus 24x equals 0. And then again, run through the same sequence. Is there a greatest common factor? If there is, take it out. If there isn't, try out your puzzle. Try out any special patterns. Okay? 1, 3, 3 x's. 1, 2, 3, 2 x's. -1, 2, 2, 2, 3, and an x. And again, factor tree if you need it. Okay? I'm going to notice a group of 1, 2, 3 3's and 1 x. So GCF here, 3x. I'm going to continue my work up front, up top, 3x, left over, x squared plus 2x minus 8. I'm going to go ahead and make that still equal 0, and let's just factor this middle piece in the parentheses. Setting up my puzzle, -8x squared on top, 2x on the bottom. I can see this is +4, -2. Remember what I said before, I like to put my negatives on the left if I only have one, that way I don't have to worry about flipping signs. And then let's go ahead and factor by grouping. So I'm going to get x squared minus 2x plus 4x, making my, minus 8. Make my two groups, take these GCFs out. I'm just going to go ahead and tell you what they were, but again, keep doing whatever work you need to help you figure those out. Getting x minus 2's, which repeat, which is awesome. And pull that x minus 2 out front, then x plus 4. And let's rewrite this equation. Don't forget about that 3x, right? We took that out first, so it's still there. Then x minus 2, x plus 4, this whole thing equals 0. So then I have 3 equations. It all comes full circle now, right? So x equals 0, x minus 2 equals 0. I'm going to add 2 to both sides. So, that's a 2, not a 3. Going too fast. So add 2 to both sides. So x equals 2. And finally, x plus 4 equals 0, minus 4, minus 4, to get x equals -4. So 3 different possibilities because I have 3 different factors. Whew, so that was quite a bit to take in. I do want you to come back with lots of questions because the more we practice this, hopefully the better it gets. So pause if you need to finish copying this stuff down. Otherwise, continue on to 1, 2, 3, and 4. All right, go ahead and check your work. So we had a couple special products in 2 and 3. So you'll see we had the perfect square trinomial, which you could have either again done with your puzzle or done with the shortcut, doesn't matter, as long as you get the proper factors. Okay, so for 1, 2, 3, and 4, check those out. 4, there was nothing beyond the GCF, so hopefully you caught that because in the parentheses we don't have an x squared, so we can feel pretty confident we're done. Okay, so please come back with questions. Obviously, I didn't give you all my work on this paper, so I'll be happy to go over anything with you. We'll do the word problem in class. Thanks for listening.